100,000 cubes is what we're going for in this tutorial. 100,000 cubes rotating and bouncing around the screen. This is Jesus Christ. Welcome back to another tutorial in C++ OpenGL. And congratulations if you've made it this far and you type your code up perfectly enough to the point that you should get this type of render or this type of application look. You should have a total of 24 cubes rotating around and marching around in somewhat of a figure 8. So let's go on. This is what you should have if you've done everything correctly and successfully. Kind of marches around, the cubes are rotating, kind of like following a figure 8 path. That's what it looks like. But this is what you should have. Okay, so this is what your code should look like. And I've been forgetting to show you the code in the GLSL shader, so I'm going to show you that as well. This is what your code should look like. Not much for the GLSL shaders. And this is what your code should look like for your main.cpp. Let me go ahead and tidy up a bit. Okay, so that's pretty much a scroll down or rundown of what your code should look like, all the code that you should have. Now, for this tutorial right here, what we're going to do, we're going to do a lot of coding. It's a lot of stuff that you're going to have to put in the, I think it's the vert shader, if I'm not mistaken. Yeah, you're going to have to put a lot of stuff in the vert shaders, okay? And you're going to have to put maybe a few things in the main.cpp. Okay, we're mostly going to be doing a lot of coding in our display, our void display, which is down here, or up here I should say, I'm sorry. Okay, so we're going to rip out everything in our void display and we're going to retype things over in that. And let's get started. Let's start at the top. The first things first, I want to go ahead and clean up my code a little bit. So what we want to do is, let's just go ahead and tidy things up. You know, go ahead and make it like that and make it look real pretty, you know. Yeah, we don't need this line anymore. We don't need this line anymore. And then we don't need this line. We don't need this line. And we don't need these lines. And we don't need these lines. Still work? Yes, it does still work. Because this up here was a for loop. This right here is your for loop. Smash these a bit closer together. And we should get started. Okay, so let's go down to our GLUint vertice buffer objects. And you want to type this line. Cancel that line out. As a matter of fact, we'll leave it there. You want to go down to your float aspect and type in time factor. And this is where we declare our time factor, because we're going to need this in order to get all of our cubes to rotate and to bounce around and fly around in the scene. And so we'll go down to PMAT, our PMAT line. This is our PMAT line, perspective matrix line. And we're going to change our camera Z to 420. I'm changing it up to 420 now. And we're going to go down to our void display. And we're going to rip everything out. This is our void display. And we're going to type in some new code. So, roll your necks, crack your fingers, shrug your shoulders, crack your backs, and get ready to code. This is GL clear, GL depth buffer bit, semicolon. GL clear color 0.0, comma 0.0, comma 0.0, comma 1.0, semicolon. GL clear, GL color buffer bit, semicolon. Feel free to pause the video so you can make sure that you type it correctly. GL use program, rendering program, semicolon. This vlock equals the GL get uniform location, rendering program, vmatrix, semicolon. And projection location is equal to GL get uniform location, rendering program, projection matrix. View matrix is equal to GLM : translate graphics library math matrix 4 1.0f comma, and then we have another GLM vec3 on negative camera X, negative camera Y, and negative camera Z, semicolon. GL uniform matrix 4FV, so view location, comma 1, comma GL false, comma GLM : value underscore PTR VMAT, semicolon. Make sure you're typing everything up correctly. GL uniform matrix 4FV, projection location 1, GL false, GLM value PTR, and projection matrix PMAT, semicolon. We're doing our time factor is equal to float current time, semicolon. Time factor location, TF lock, GL get uniform location, rendering program, TF. GL uniform 1F, TF location, float time factor. GL bind buffer, GL array buffer, comma, vertice buffer object with an array of 0. Use square brackets, semicolon. GL vertex attrib pointer 0, comma 3, comma GL float, comma false, comma 0, comma 0, semicolon. GL enable vertex attrib array 0, semicolon. GL enable GL depth test, semicolon. GL depth func, GL L equal, semicolon. GL draw arrays instanced, GL triangles, comma 0, comma 36, comma 100,000, semicolon. Now we're going to go down our int main. You're going to type a void window size callback, glfw window, star, win, comma, int new width, int new height. Want to type void? No, we don't want to type that, sorry. You want to type aspect equal to float new width divided by float new height. GL viewport 0, comma 0, comma new width, comma new height, semicolon. You want to type pmat is equal to glm colon colon perspective 1.0472 float, comma aspect, comma 0.1 float, comma 1000.0 f. Alright, so now we're going to jump on over to our frag shader. There's nothing to be changed here, but this is what your frag shader should look like. I think I showed you this before. We want to go in our vert shader and we're going to code something from scratch. Beneath your version 4.3, you want to type layout, location equal to 0 in vec3 position, semicolon. And beneath that, you want to type uniform mat4 view matrix, semicolon. Under that, you want to type uniform mat4 projection matrix, semicolon. Then uniform float TF, semicolon. Underneath that, I'm going to type out vec4 varying color. You want to type mat4 build rotate x float rad, semicolon. You can type mat4 build rotate y float rad, semicolon. You just want to copy and paste it again and replace it with a z, capital Z. I'm trying not to get too fancy because try not to show off because I might make a mistake. Mat4 build translate float x float y float z. And we want to go down to our void main, void. You want to type the following lines like so. Float I is equal to GL instance ID plus TF, semicolon. You want to type float A is equal to sign 203.0 multiplied by I divided by 8,000.0 multiplied by 403.0. 0.0, semicolon. Then we want to do something for float B, and then we'll do the same. We'll do something different for float B. Float B, and then float C. I'm sorry. Float B, cosine 301.0 multiplied by I divided by 4001.0 multiplied by 401.0, semicolon. Float C is equal to sine 400.0 multiplied by I divided by 6003.0 multiplied by 405.0, semicolon. I'm not going to keep reading it. Just pause the video if you need to slow down. Notice how all these lines look the same, but they're not the same. This line represents x-axis. This line x represents y-axis, and this line represents the z-axis. Okay, local rotation z. Okay, R has this is a capital R, capital Z, capital R, capital Z. Have 4 local trans equal to build translate A, B, and C, semicolon. So a lot of stuff that you're gonna have to type. Okay, so now that we typed all this code up, we should see 100,000 cubes rotating, bouncing, and flying around. Just keep your fingers crossed. Let's hope we get the results that we're looking for. GLUNV lock. Okay, let's cancel that. What is it saying? It's saying redefinition of GLU end project projection location. Alright, let's just go ahead and cancel that out because we have this up here. So let's just cancel this line out. That's what I would do. And let's run another rebuild and see what the results are. Aspect and time factor. Let's put a comma there. Yeah, that should be a comma there. Let's run a rebuild again. And we should get the results that we're looking for, which is 100,000 cubes. There you go. And this is what we've covered. We covered this page right here. I think we're still in chapter 4. We're on page 82. Which is still talking about instancing. So go back in the section and read, and you'll have an understanding of everything that we just typed. Everything that's showing up here in the yellow highlighting is the stuff that we just typed. This is page 82. Alright, so that's our tutorial, and thanks for watching, and I'll see you in the next tutorial. In the next tutorial, we're going to cover a cube and a pyramid. We're going to make those two render in the same scene. It's not going to be anything fancy going on. If anything, this is more exciting than the next project, because you're actually seeing stuff moving around and flying around and stuff like that. But yeah, this is the next project that's going to be coming up. So thanks for watching, and if you've made everything, if you typed everything up correctly, these should be your results. If you typed everything up correctly, congratulations. I'll see you in the next tutorial. It's Jesus Christ. Thanks for watching.